just wanted to basically provide an introduction that this is my YouTube channel. So welcome if you're watching live or if you're watching the recording. If you're watching since the beginning, you've already heard me say these things. But basically, we had some technical issues. Now, this series, She Can Cloud Native, is really to highlight the efforts of women in the space. And I already had several different live streams, and I'm going to continue to have it more or less every week. If you know somebody who you would like to have on this live stream, then please do let me know. I would love to hear from you or anybody whom you would recommend. Now, this live stream is sponsored both by the company that I'm working for, Acra Security, as well as Commodore has helped me set this live stream up. Now, as you can see, it doesn't always go as expected, but we're working on it. So huge shout out to Commodore and Acra Security for supporting this kind of work. Now, we have Hannah here today, and I think now we can finally hear Hannah.
Hi.
Hi. Thank you for bearing with me. See, it's not just you.
No.
Every time I have Hannah on a live stream, just to provide context, the video doesn't work. She can't connect. Then the audio doesn't work. So now we have figured everything out, and I think everybody can hear me. Yes. Thank you for this amazing supporter in the chat who tried to make me aware of my voice not being audible. But I really want to hear from you. So why are you on this live stream? Why did I invite you on this live stream? I love to ask people that question. I was like, why do you think I asked you?
I believe you asked me because, well, I'm a female, and I love the cloud native community. It's such an engaging community who wants to help one another, and even though I'm not actively working within the cloud native community, I still love to learn and share what I'm learning and try out different tools. So perhaps that's why you asked me, I think.
Yeah. Can you provide for the people who don't know you, kind of like a background story of like who you are and what qualifies you to give an introduction on Kubernetes?
It's a good question, right? So I'm Hannah Seligson, and I'm currently a developer advocate for a company called HubSpot. But before that, I was a software engineer, and I was mostly back end. And so I worked on building and designing APIs. And then afterwards, that's when I got into advocacy. And then my first advocacy role was for a cloud native company called CodeFresh. And when I was at CodeFresh, that's when I really needed to learn Kubernetes very quickly, because when I was an engineer, we hadn't yet containerized our applications, but it was something we were in the process of starting. So we had taken like our monolithic systems, broke them down to microservices, and now that was our next step. And so I guess what qualifies me is that I was an engineer who was kind of on this like legacy side of things where I did not work for a very modern company. So everything that we built was very manual, very slow. And so when I worked and worked within the cloud native community, I was like, oh, wow, like these are tools that when I was an active engineer, we could have really benefited from. And so I just dove in and really wanted to learn, how it can help developers, why, and just want to make it a little bit less scary for developers so that they're excited to get to know these different technologies.
Yeah. So when you were working with microservices applications,
yes.
Did you also work with containerization tools such as Docker? Like, was that something you already know about? So how did you? Okay, so me being very ignorant and not knowing how people deployed applications before, I'm curious right now. How did you run those applications? If you
they were manual.
Service applications did you even have? Like hundreds? Like.
Well, so we were an insurance company, and we had and so we did like commercial business insurance, and the way that we did our deployments, like we had actual large physical servers that were in a separate state, and that was like what hosted our systems, and we had like a separate, very large like DevOps team. And everything was just a bit outdated and very clunky. And I remember when we would have outages and the effect it would have on, like, because oh gosh, like it would be terrifying because
You're reliving those memories now.
yeah, I just remember like you would see like the CTO, the VP of IT, all of the management. They would get into like a Microsoft Teams chat. It was very grossly named like the war room, which I didn't like, but it was like that's where like they would be like, what happened? Why did this happen? And like trying to implement a fix like in the middle of the night, and it would just be chaos. So
it's very stressful.
very stressful.
So you're glad you don't have to do that anymore.
Yeah.
Related to these.
Yeah.
Yeah, that makes sense. Okay, so I'm gonna ask you after the presentation probably like how your life changed and how like basically the experience before versus after, because I, for example, I don't have that, right? I don't have the experience of before versus after, like versus me discovering Kubernetes. There's not a thing, right? Like for me, it's just one way of doing things. So yeah, but I really want to see the presentation, and then we have, I guess, more of like a common context to talk about.
Yeah.
So if you want to just dive in,
Cool. Yeah,
that would be amazing.
Alrighty. Let's see. Okay, so I love this meme, but I feel like as a developer who, like I had mentioned, never worked with any sort of like cloud technologies, and someone who truly doesn't even know what a container is, when you read this definition from Kubernetes is an open source system for automating deployment, scaling, and managing of containerized applications. It almost seems like it's a mystery and you don't understand how it works. And then I feel like one looks at the Kubernetes documentation, they see the architecture, and then they're immediately overwhelmed. And I empathize with that, and I understand that. And what I'm hoping with this presentation is that we can kind of review the primary components of Kubernetes and how that essentially builds your containerized application and helps you deploy it. And then also I want to be able to share just some resources. We'll talk about like some common misconceptions developers have about Kubernetes. And I'll try to make this as casual as I can. I also wrote notes because with Kubernetes, there's so many different pieces that I want to make sure I'm accurate. So if you do see me referencing notes, it's because it is complicated, but I'm going to do my best to make it not complicated. So first, when you're trying to understand what Kubernetes is, it's referred to as like an orchestration system because what it does is it automates and it coordinates the deployment, scaling, and your management of your containerized applications. And it's designed to basically manage complex and large number of containers across multiple nodes. And I'll get into like what exactly a container and a node is further down. And when I say like it's handling just a lot of different containers, I mean they're handling not just 3 or 4, they're handling hundreds, thousands, hundreds of thousands. So it's like if you imagine, trying to manage all of these containerized apps manually, updating scripts, configurations, and so forth, that's a lot of work and that's a lot of time. And so that's kind of one of the reasons why Kubernetes is using it as a platform to orchestrate those containerized apps, hence the orchestration, is so important and so helpful. Because in traditional deployments, applications are typically deployed on a single server or like a small number of servers. And as the number of servers and applications grows, then, like I mentioned, that's when it gets really hard to manage them and scale that infrastructure. And even when I was a developer, scale was one of our like biggest issues. We didn't know how to properly scale everything. And also like another issue that we had was that we weren't able to monitor everything. And we were looking into tools like I remember we were going to utilize like App Dynamics. And I haven't used that tool in a long time, but that was one of the options we were going to use before we even put anything in the cloud. But anyway, so with Kubernetes, developers can deploy and manage containerized apps across a cluster of nodes. And I'll explain what a cluster is later. But Kubernetes takes care of like scheduling the container on the nodes, monitoring the health of the containers, and then scaling the containers up or down based on like your end user, your demand, how many people are using it, and then rolling out any updates without any downtime. So like I mentioned before, like when we would roll out an update and then it would break our systems, we would be down for possibly a day or two. And that's a lot of money you're losing from a business perspective. So yeah, and so Kubernetes also provides like a rich set of features that make it easier for developers to manage their apps, such as like a service discovery, load balancing, and then automated failover. And it's essentially those features that help ensure that the apps are available and then they can withstand those failures. So basically, I'm trying to understand the concept of Kubernetes as an orchestration system is really important for developers because it lets you take advantage of the benefits of containerization without having to manage your infra manually or have like a large DevOps team managing that for you. And it's good because this then frees up time for developers so they can actually focus on their development work and roll out features quicker and release to prod daily, if not multiple times a day. And that'll ultimately just help your business grow a lot more. And so I'll stop if there's any questions, but that's essentially kind of an overview of what Kubernetes is and why it's really helpful. They'll get more into why it is helpful.
Yeah, there are no questions in the chat right now. If you have any questions, post them in the chat, or if you're watching the recording, post them in the comments and we will address them afterwards. I just wanted to reiterate that, I mean, I don't know how people did it without Kubernetes, but when you're scaling an application, you need multiple replicas, like multiple instances of the application, so more people can access it. Mm-hmm. Managing the data consistency between those different instances, I think that's one of those things that I, for example, don't know how that has been done about Kubernetes, right? Like if one of your systems is down, how do you know which data is saved there versus on another instance, right? That where people already appended new information, right? And then when you spin up the system that's down, to make sure that that's again up to date with the new state of the other part of the application that has been still running in the process, right? So that's one of the things that I was just thinking while you were talking about that.
Yeah, because I think also with containers, it's really helpful when if you have multiple containers in a pod, because you want your containers to be closely associated. So with your data and your storage and so forth that applies to your application, you can put that in a separate container within the pod. So if that container does go down, it'll be easier to replace. And it's kind of like I think they call it like a helper container or something. Maybe it's a sidecar. Maybe I'm getting concepts mixed up, but yeah. So anyways, so essentially the reason that Kubernetes came to fruition was the rise of microservices. So like I mentioned, where I was breaking down those big legacy systems into smaller microservices. And this is what led to the increase of container technologies because they offer the perfect host for small independent apps like the microservices. And so as a result, the industry with modern applications, they're now comprised of all of these different containers, and you can manage those containers using scripts or any sort of like self-made tool. And that can be a bit complex, and sometimes it can seem impossible. So to solve that problem, container orchestration, like technologies like Kubernetes, that's why they exist, because it guarantees what I mentioned, like high availability, scalability, and disaster recovery. And what I mean by high availability is that it means that the application has no downtime and it's always going to be accessible to users. And scalability allows applications to quickly scale up or down, just adjusting and increasing and decreasing the loads. And then your disaster recovery is going to ensure that if there's a problem with your infrastructure, that your data can be backed up and restored to your latest state, so the app doesn't lose any data. And when I say state, what I mean is that when you are working on an app, you have that current state, right, that you're working on. But maybe you're adding a new feature or you're fixing a bug, and that next stage is going to be your desired state. So Kubernetes is always going to ensure that you have the latest state of your application. And if you don't, there's tools that will automate, that will help you recognize that. But it's important to know. And Kubernetes offers all of those functions, and it really makes it a valuable tool when you are managing tons of containers. And the basic architecture of Kubernetes consists of a master node, or otherwise known as like a control plane, your worker nodes, and it coordinates tasks while the worker nodes run containers and manage their workload. So together, the control plane and worker nodes form like this powerful tool that can manage large numbers of containers across multiple different environments. Okay, so this is my handy dandy just demonstration of essentially kind of just a cluster, but more so the Kubernetes architecture and how it works. And so the Kubernetes architecture, it's based on a set of different building blocks that work together to create just a flexible and a scalable platform for your containerized apps. And the main components of Kubernetes that I'm going to talk to you about is essentially like your cluster, your node, your pods, and your container. And just kind of a brief overview, a cluster consists of like a set of nodes that run the containerized apps. So this is your worker node, here's your pod, and then here are all your different containers. And each node is a physical or virtual machine that runs your Kubernetes software, but it's also capable of running all these different containers. And those nodes are actually connected to each other through a network, and they communicate with each other using a Kubernetes API. And then the pod is actually like the smallest unit of your deployment, and it essentially represents like a single instance of a running process in a cluster. And it can contain only one container, but it can also contain several. And those pods are used to encapsulate and manage the container that makes up your application. And they essentially just provide a boundary around the containers with a shared network namespace and storage volumes. And then a container is essentially a lightweight, portable, executable package that contains everything that you need to run your app. So within the container, you're going to have your source code for your app, your runtime, your system tools, your libraries, and your settings for that app. And the containers are what essentially allow developers to package their app in just a consistent and a reproducible way. Like Anissa mentioned, something that you can share with others, which makes it easier to deploy and manage applications across different environments. And the way that you can share your containers with a container image, but I'll explain that a little bit more later. And then finally, your node is like what I mentioned, the physical and the virtual machine that runs your Kubernetes software. And the nodes are connected to each other through a network, and they communicate with each other through the API, and they're just essentially for running the containers. So together, these main components of Kubernetes are your building blocks that form the basis of the Kubernetes architecture. And this is what allows you to have a much more scalable platform for your apps. So is there any questions or?
Yeah, no questions by now. It's a great explanation. Awesome. I love the drawing.
Thank you. Okay. So now we're just going to take a better look as far as what each of these components of Kubernetes does. What do they contain? How do they communicate to one another? And first, we'll start with containers. So containers are, like I mentioned, just a lightweight package that contains everything you need to run your application. And containers provide a consistent environment for your running apps across different platforms, and they allow devs to package and deploy your apps quickly and efficiently. And they're also, what's nice is, I think, is that they're isolated from each other, which makes it a lot easier to manage and scale your apps. A container in Kubernetes is deployed as part of the pod, and containers in a pod share that same network namespace, which means that they can communicate with each other using a local host. And a pod can contain one or more containers, which then are deployed and managed as part of that pod. And like I said, they share a lot of resources. And Kubernetes even provides like a set of services that can be used to expose a containerized application to the outside world. And those services provide like a stable IP address, the DNS name for the app, which makes it really easy to access the application from other parts of the cluster or from outside the cluster. So that's essentially what a single container contains. I was thinking of like getting trying to do like a puppet thing and like explain like, here is your container, and then like I was like gonna do a box within a box, because someone had made a joke how Kubernetes sometimes seems like those I forget what they're called, but they're these Russian dolls. They're made out of wood.
Oh yeah. What are they called?
Yeah,
like one inside of the other, inside of the other.
Yes,
so and inside you have the deployment and the pod and the container.
Exactly.
Yeah.
And so I really wanted to like have something to like physically show, but hopefully this helps.
That's good. For next time.
Okay, and so now we'll talk a little bit about pods. So while container does contain your app and its dependency, it's actually the pod that really helps us. So by definition, the pod is a unit that hosts the application instance for one or more containers. And the primary responsibilities of a pod are to actually run those containers. So they allow you to run them as long as these containers are tightly coupled and they share the same life cycle. And what I mean is that you want to make sure that these containers are associated with one another. You don't want to have two completely different applications within a container, because by having them associated with one another, it makes it easier to deploy and just manage them. Also, pods share resources. So as I mentioned, the container and the same pod, they share those resources, and that resource is like the network, the namespace, the storage, and their process ID space. And this is what actually allows them to communicate with each other, kind of using like a loopback interface and by sharing files. And then pods also, one of their responsibilities is for networking. So pods have a unique IP address, and they communicate with other pods and services within the same cluster. And they can also expose their services to an end user using one of the Kubernetes services. And pods also, they also help with monitoring the health. And what I mean by that is that Kubernetes keeps track of the status of each pod and reports any issues that are going to occur. So this really helps you when you want to ensure that your application is just up and running, there's no issues. If there is any sort of health issue, then it's going to let you know. And then as far as resource management, pods can be assigned resource limits, requests, and this is what helps Kubernetes manage resource allocation, any sort of utilization. And this just ensures that your app is running and it's doing well. So an example of this is that, let's say that you have a web application and and this is kind of what I mentioned actually before, it needs to communicate with a database. And so you create a pod with two containers, and one for the web application, and the other is helping that container by handling the database migrations. And so that web app container would be like the main app that's handling incoming requests from end users. And then the other one would be a helper container. And that's going to be helpful for managing the database schema and then performing any sort of like migrations that are necessary. And when the pod is created, both those containers are going to start together. They're going to share the same network, such as like your namespace, and then it's going to allow them to communicate with each other using the loopback interface. And the web app container can then connect to the helper and with the container's IP address and port to access that data migration tool. So if the helper container fails for whatever reason, Kubernetes will actually be able to restart it automatically. And so that ensures that the database schema is always up to date and that the web app remains functional. And this approach with containers and with pods, it really allows you to keep the main application container lean and just focus on serving user requests while delegating any background tasks to like a separate helper container. So I hope that kind of helps you understand that. Okay, so now I'm going to dive into nodes. So a node in Kubernetes, it refers to as a worker machine. So that's why you'll often see like worker node. And this essentially runs one or more pods. And so this node, it can be a physical machine or a virtual machine, and it can run on a cloud provider. And each node has its own CPU, RAM, and storage resources. And the node includes several components such as like your kubelet, your container runtime, your kube proxy, and pod networking. And as far as like what is contained in a node, so you've got kubelet, and that responsibility is essentially that kubelet is an agent that runs on each node. And it's responsible for ensuring that the pods are running and they're healthy and they're communicating with Kubernetes, the Kubernetes control plane. So I don't want to mess. I always get confused with slides. I'll go to look at a reference in different slide and then I lose it. But essentially, the control plane that it's communicating with, or the master node, what it's doing is it's actually receiving instructions on which pod to run and then how to configure them. And then your container runtime, which is this right here, this layer, this is actually the software that runs containers on the node. And Kubernetes supports all kinds of different runtimes. And if you're familiar with Docker, which 9 times out of 10, most of us are, that's what this layer would be. And then you do have like your kube proxy, and this is a network proxy. This is going to run on each node, and it's responsible for forwarding traffic to the appropriate pod. So it handles the load balancing and the service discovery. And something that I didn't actually include in this diagram is pod networking. So pod networking is a network interface that allows a pod to communicate with each other across nodes. Kubernetes supports several pod networking solutions like Calico, Flannel, I believe WeaveNet, sorry. But something that I want to point out that I did before is that there's this worker node, and then we had that master node. And so let's kind of go into that and explain what are the difference between those two different nodes. Okay, so like I mentioned before, they're communicating. This is a worker node, this is your master node, or aka your control plane, and they're the ones who are communicating with one another. The master node is responsible for managing essentially your cluster, and it's controlling the overall state of the system. And it runs a lot of different components, including the API server, etcd, your scheduler, and your controller manager. And those components work together to manage your cluster. And it's going to also schedule pods. It's going to work with your nodes, and it's going to ensure that your desired state of the system is maintained. And it's that master node that also provides the interface for developers so that they can interact with their Kubernetes cluster. And you can use that with a kubectl command or anything depending on what kind of cluster you have. And then your worker nodes are going to be responsible for running the containerized apps. So they run several components, like I mentioned before, the runtime, the proxy, the pod networking, and they just communicate with your master node, and they just receive instructions on which pod to run and then how to configure them. And then one last thing about the master node. So when you are using the master node, can also be used when you're setting up your Kubernetes cluster for the first time. So when you are making any big changes to the cluster, that's essentially what you'll be doing. The master node is responsible for managing the whole system. It's just ensuring that your desired state of the system is stable and maintained. So that's kind of what that relationship is like. So when you are setting up a Kubernetes cluster, the master node should be used to manage the system, while the worker node is going to be used to run your apps. And then as far as like the difference between a control plane and the master node that I mentioned, really there are no differences. Earlier, I guess, versions of Kubernetes, the term master node was commonly used to refer to the control plane components. But just with recent versions, the term control plane is preferred. So that was always something that confused me. And actually, someone asked me a few weeks back. So I just wanted to mention that and clarify that.
Also, maybe I think that's true, but I'm not 100% sure of what I'm about to say. But I think it's true that a lot of times you don't even have access to the control plane if you're using managed Kubernetes. Like,
yeah,
in some managed Kubernetes, like I think, for example, DigitalOcean, they are giving you access, and in some other cloud providers, you can get access, but I'm not 100% sure.
That's what I thought.
You don't get access, right?
Yeah.
I just want to say that usually you don't like touch it if you're not like dealing with actually the underlying component.
Right, exactly. Yeah. Okay. So now we'll talk about a cluster. So I just need.
Take your time. You're talking a lot.
I'm trying to be quick. I'm like, wow,
no, it's great. It's great. Take your time. You have time to take a sip of water. Okay. Maybe we can answer real quickly a question. And I let you rest for a second. So somebody's asking, I don't know how to pronounce your name. Pavar is asking, I just started my learning journey as a front-end developer. So is it a good idea to learn Kubernetes and Docker alongside this? Is it a benefit to make my profile more diverse? Generally, what I would, with my perspective, is that knowing Kubernetes, using Kubernetes more than deploying application, like knowing it to this extent, like Hannah is explaining the details, right? But usually, like if you're just deploying applications, you don't have to know the inside out. If you're not the SRE or cluster admin or DevOps engineer, you don't have to know how to fix these components, right? And I think that's worth noting that. So in those cases, I would say you should know as a front-end engineer how to package your part of the application, how to build a container. Like I think is if you're working for a company that uses containerization, that's one of the things that will help you because people won't have to advise you on these things. And it's a lot of times now from engineering teams, it's kind of expected of like package your own application, like with shifting left and everything. It's more and more done by the developers, like by the engineers themselves. But I don't think you have to know the insides out of using Kubernetes. Now, it depends on the organization as well. Like some organizations, especially, I guess, startups, will expect you also to build the YAML manifests, right? Like that would be my perspective. What do you think, Hannah?
Yeah, I agree. As a front-end developer, I don't know if it is really critical for you to know if you are, but also maybe you're building your own app. Maybe you want to know how to do this. In that case, yeah, this could definitely be valuable for you. But essentially, Annie's mentioned it perfectly that it's going to be those manifest files that are going to be the most important. And I will definitely touch on that a little bit and explain like, what are Kubernetes objects and how are those created? And typically it's just through a YAML file and JSON and and we'll talk a little bit more about.
Also, when you get started, you can do a lot of copy paste.
Too. Yes, there's so many resources out there. Yes.
Forget it. I let you continue now.
All right. So lastly, the last component I really want to explain is the cluster. And so a cluster consists of two main components. So it's going to be your control plane and then also your worker node. And sometimes actually worker nodes are referenced as compute nodes. So just FYI. But your control plane is responsible for managing and controlling the cluster, and it runs several key components. So as you see, we've got like this API server, and that server is the central management point for your cluster. And that's what actually receives and processes any REST API requests from your kubectl commands or any other Kubernetes components. Then etcd is a distributed key value store that stores the configuration data of the entire cluster. It provides a way to store and retrieve data that's needed by the control plane and the worker nodes. And then your controller manager, it actually watches the state of the cluster and it makes any necessary adjustments just so you can keep that desired state that you need for your system. And it also includes several controllers, including like the replication controller, endpoints controller, service account, and token controllers. And then that's where things can kind of get complicated, but I won't get into and explain what that is. But lastly, then there's also a scheduler. And the scheduler is going to assign new workloads to worker nodes based on your resource availability, and also any sort of constraints that you're having and any sort of workload requirements. So together, that control plane and your worker nodes form a distributed system that run and manage those containerized workloads at scale. So here's where we get into that deployment object we were just talking about. So based on everything that I've talked about, you can see that Kubernetes definitely supports the deployment of containerized apps through the architecture of nodes, pods, and a cluster. However, in order to deploy a containerized app, this introduced the concept of a deployment object, which is used to define that desired state of your app. And this can also include your container image and any other settings. So the deployment object is a declarative configuration file. It defines how a containerized app should be deployed and also managed on the cluster. So this object specifies the state of the app, including the image, the number of replicas to run, and then any sort of environment variables, networking, and storage. And so with the deployment objects, the developer can define the state of their app, and then Kubernetes is going to ensure that the actual state matches the desired state. So for example, if a deployment object specifies 3 replicas of a particular container that should be running, Kubernetes is going to ensure that there are always 3 replicas running, even if one or more of them fail or if one of them terminates. So by using a deployment object, devs can simplify the deployment and the management of their containerized app on the cluster and just ensure that their apps are always running and that they're available to end users. So within this actual example here, the deployment object is defined by apps v1 and then the API version, or the API version apps v1, and then the deployment kind. So that's what this is. And then the metadata section contains like the name of the deployment object. So I've got like my app deployment, and then the space below defines the desired state of the deployment, including the number of replicas, the selector for identifying the set of pods that we want to be managed by this deployment, and then also the template for creating new pods. And so just a note, a replica set is just kind of a high layer abstraction that lets developers manage and scale multiple instances of a pod in a cluster. And it's responsible for maintaining that specified number of identical replicas of a pod, just ensuring the state of the I'm trying not to say replica too many times, but essentially it maintains that specified number of replicas of a pod and ensures that the desired state of the replica matches that actual state. So that way, if a pod just becomes unavailable, that replica set is going to automatically replace it with a new one. And then the container section specifies the container image to run. So I've got like my app image latest. Just a tip, I probably wouldn't use latest. I would use something with a specific version. You can use also like a generator to get a specific code, because sometimes when you do request latest for your container image, Kubernetes doesn't know what that is. At least I've had that happen to me before. And then also it has the container port and the environment variable as well. So, and then just to clarify, because I mentioned this before, a container image is the same concept as a container. It's an executable package that contains everything that you need to run your software. And it so includes your code, the libraries, the system tools. And it's just a snapshot of the application and its dependencies at a specific point in time. So container images can be compared to like a virtual machine image. They're just much smaller. They're a little bit more portable, and they only contain the app and its dependencies. So yeah, and usually container images, they're stored in a container registry. So if you're familiar with like Docker Hub, which I use, I believe Anais uses, like Google Container Registry. Those are ways that you can easily share and distribute your containers with your team, and also just end users or anybody you need to share that with. And then there are also different objects, and I'm not going to get into each one because we would be here for another hour. But basically, a Kubernetes object is just a persistent entity that represents a desired state of a cluster. So it's going to define any characteristics or behavior of the app. And it's such as like how many instances of the apps should be running, what network ports the application should use, and then what resources it should consume. And then an object is just defined using a YAML or a JSON config file. It'll be stored in your source control and then version, and unlike any other code that you're doing. And then once created, those objects are stored into the Kubernetes API server and managed by the controller manager. And so this is just some examples of those different types of objects that you would typically use. And I won't get into each one, but
that would take us some time.
I know. But just lastly, what I wanted to touch on is just the evolution of containerized deployments. So in this diagram, I have, for example, like your traditional, your virtualized, and your container deployment. And deployments have definitely evolved over time. A traditional deployment typically involves a manual configuration and deploying applications on individual servers, which has its downfalls when it comes to scaling, when it comes to just having outages and errors. And it can also just be really time consuming to maintain. And then a virtual deployment introduces the concept of virtual machines. So this allows multiple applications to run on a single physical server. And this approach is a lot more flexible. It also allows scalability, and it's also easier to manage and deploy the apps. But it definitely introduces some overhead and complexity because a VM requires its own operating system. So it's it's definitely much heavier than a container deployment. And then your containerized deployment, they just take that idea of virtualization a step farther by using container technology. And that's what allows us to have multiple apps run on a single operating system without all of that overhead that you get with a VM. And this approach is a lot more lightweight. It's just portable, efficient, and it's a little bit quicker than these other methods of deployments. So overall, containerized deployments definitely represent just a significant evolution, the way that applications have been deployed, how they've been managed, and they just offer so much more flexibility that allows developers to focus on other things, which I think is the biggest benefit. So yeah. And then I don't know if we have time, but one last thing I want to mention is that this is something in Twitter that I was talking about with a friend, and they were like, developers keep like confusing containers as mini VMs. And I don't know, I guess I would like to know your input. I'm kind of on the fence. I get why, like from an architect standpoint, they're different. So for example, like with a virtualized deployment, you have this hypervisor layer, and VMs use those to create and manage the machines. While containers, they don't use that. They use a container engine. So like Docker to create and manage containers. And then also just went from like an operating system perspective, each VM runs its own complete operating system. So that takes a lot of resources. And when I talk about resources, when it comes to allocation, VMs are allocated a fixed amount of resources. So this means like their CPU and their memory when they're actually created, and the containers can actually dynamically allocate those resources based on the needs of an application. And then just kind of simple things like when it comes to startup time, VMs take a little bit longer. Containers, you can start up in just seconds. And then also just the size, like VMs are big. They're going to contain a complete operating system, and that is all of its dependencies, while the container just includes its app and their dependencies. So it's not the entire system. And so that's kind of that primary differences between the two. So Kubernetes can be definitely used to manage container running on VMs or bare metal servers, but it's not virtualization technology itself. And then lastly, I love this photo. I saw it on Twitter, and then I saw someone recently posted on LinkedIn, because I very much felt like this person, where when I was learning Kubernetes, it was a huge leap. And I feel like when you are new and you want to start learning about Kubernetes, pace yourself. And because there are certain concepts that are going to help you with the learning curve. And what I mean by that is that I think it's, first you can always reference Kubernetes documentation to get a good idea about it. There's so many resources that we'll also share. But I think it's really important to understand like what networking is, what is the cloud, have some basic web development skills, understand what Linux is, and get comfortable working within a terminal. Because even as a developer, I worked mostly within, Visual Studio Code, and I worked, with our database. I didn't really work with different tools. So in a lot of those tools, you're going to be accessing your machine. So just getting comfortable with those basic things first are going to be really critical. At least for me, it did. So yeah. And then lastly, I did come up with like a list of resources. I can share this list after this presentation, but I just think with Kubernetes, it's a big learning curve. But what's so wonderful is that so many folks have already created so many resources that are free, that are maybe low cost, they're easy to access. So don't think that you have to learn this alone or don't think that you can't ask questions. I had a friend of mine who was asking, with Kubernetes, how do I scale? And I was like, great question. And so, just asked some folks, got some resources and tools for them to check out. I think what's so nice is that this community is so helpful, and compared to like the development community that I was part of before, I felt very isolated. As compared to this, I don't. And I feel like we all just want to help each other and, follow best practices and do our best. So yeah, that's that.
I have to unmute. Not making that mistake again. Amazing. Yeah. Awesome. Thank you. That's amazing. If there are any questions right now, please post them in the chat, or if you're watching the recording, post them in the comments, and we will address them at some point. Yeah, this is really great. What was your perspective coming from a developer background? What did you struggle with the most? Getting started with Kubernetes and containerization.
I'm trying to think. I think for me it was putting all of the pieces together and trying to understand, trying to understand the layers of a cluster really is helpful, because that's typically what you're going to be working with the most. And if you run into any sort of errors, sometimes they're just oftentimes I had the experience, it was a user error, something that I did before that I maybe, goofed something up and I wasn't able to get things going or things like that. So I think it's just understanding a little bit of context about how something is built, specifically the cluster, that helped me the most. And then we didn't even get into frameworks for your config files or actually go through the deployment process. So there's so many other things, and there's so many tools that you can use. And sometimes even that can get overwhelming. But I think just starting off small, with just, a couple containers, a couple apps, and seeing what works best for you, I think is the best way to go. So if you're trying to handle, trying to change the culture of a company's, how they build things, it's going to be hard. So I think starting slowly and seeing, vetting tools and seeing what tools are best for you. So yeah.
Awesome. Definitely. Something I found when I got started is that I would read multiple different resources at the same topic in order for it to click, basically, in order to understand what it's trying to what people are trying to explain, right? So a lot of times I think a lot of times it's just the more you read about it, the more you will understand it. Based on this, if you're watching this presentation, you're hearing about Kubernetes and the different components for the first time. Don't worry if you're not getting it. If it doesn't make any sense, just keep watching more resources, and then it will make more and more sense. I don't think there is this one true resource that will give you the magic key to understanding how to use Kubernetes and how it works under the hood. Right?
It's true. Like someone had mentioned in the questions, at what point we should consider that as ready. Practical implementation and POC is more than enough. I think, from my opinion, I think, yes, it is there's a lot, but I think when it comes to actual implementation, ensure that your developers have at least a general understanding, and take the time to onboard the developers, and take the time to also reach out to people to see which tools are going to be the best tools for you and your team, and also depending on your size. And I would start off with maybe I would start with a POC, start with one application, a smaller service, and go from there. I think would be the best route, and actually implement a workflow and a process for that, from the developer submitting their code to releasing your code into production, and recognize how long that process takes. What are areas that you're missing? Maybe you're missing a security feature that you need to implement. Maybe you need an automated way to recognize the health checks. Maybe you need an automated way for rollbacks. And that's when those different puzzle pieces for your deployment process come into play. And so, yeah, I would definitely just start there. I don't know about you, Anise. What would you suggest or say?
I feel like it's similar to constructing a house and building a house. Mm-hmm. You wouldn't go ahead and build an opera house straight away, right? Or a concert hall or something. You would start with something more attainable first. Because ultimately, like if something smaller, I guess, collapses or doesn't work as expected, it's not such a big deal. Like you can fix it, you can easily fix it. But if you're migrating your entire infrastructure all at once, then it's far more likely that things are not working as expected, or you might overlook components, or if you have hundreds of microservices with different endpoints, it's far more likely that you're maybe exposing those to security risks versus if you have just a handful of services of applications you have to manage. So I would definitely, again, start small and then expand from there. As a developer, I think knowing how to manage your own application, or like something small scale and a proof of concept kind of environment is enough until like you have certain expectations being set by a company. I mean, again, you're probably not going to be a cluster admin who's managing all of the Kubernetes components themselves. Like those are very specific roles and very specific companies that most people have to know how to deploy applications to some environments.
Yeah.
So these are all of the resources that helped you.
Yes, these are a list of resources. Yeah, that have definitely helped me. And yeah, and even yourself, like you have 100 days of Kubernetes, and I definitely referenced that when I was starting. But I would even start like this DevOps bootcamp, like understanding Linux and Bash, and then getting into like these introduction courses and taking it a step further, because it really, the first time it might not make sense. That's okay, because that we've all been there. And I think the more you review it, the more that you refresh yourself, and also the more experience that you have with it, the more you're going to learn. So don't expect to be an expert and be following best practices from day one. I don't think that's feasible for anybody. But I definitely think, we were even chatting before this presentation that like, hey, like, even within our career, there's times when you forget certain things. You're like, wait, how does that work? And you need to refresh yourself. So that's, we're human. Our brains sometimes can only consume so much. So, yeah.
Yeah, or also regarding the question on proof of concept environments, I work on open source tools at Aqua. I don't interact with production large scale environments at all. Like if people come up to me and ask me certain things, for example, about service mesh or like very more advanced networking topics, let's say, I wouldn't be able to give them clear answers because I'm not doing it myself. So, like you don't have to know all of these things. It's unattainable most cases. Yeah.
Absolutely. And it does. It takes time and experience. So yeah. Hopefully this kind of just gives you a little bit of an aha moment, like, oh, okay, that's how that, puzzle works, or how they all intertwine. So yeah.
Also, something that I, for example, did wrong is I jumped straight into Kubernetes without knowing much about containerization. Like I knew the basics on how to build and run containers. I didn't know the details. And it was just, we could talk like for hours about containers first before talking about Kubernetes. And I think that's one of the issues that I since then run into a lot of times, that things wouldn't work. And I wouldn't necessarily think about the issue coming from the container themselves versus the orchestration system, in that case, Kubernetes, right? That's one of the things. Like, don't get started with Kubernetes unless you're familiar with containerization tools such as Docker and
100%. Because like you said, you'll run into an error and you'll be like, why is this happening? And it really will help to have that extra context or understanding to pinpoint that, so you're not stuck, or you're not facing a roadblock for a long time.
Also, something that I realized since working at Aqua, that ultimately anything like that, any security issue that you have in your application or in the container, everything will trickle down into Kubernetes. Like if you don't fix those issues, in that case, security issues early on, they will still be there once you deploy the application. Like it's not going to go away by wrapping another layer around it, right? So I think that's what a lot of people don't realize as well. So but that's also a different topic.
It's a great though. It's true.
James joined us. Thank you for joining us. um, Amazing. It's towards the end of the live stream. Is there anything else you want to share, Hannah?
No, that was it. Thank you for having me.
Thank you for taking the time, also preparing this very detailed presentation. Again, creating content, creating presentation takes time, and I really appreciate it. You took the time for this channel to create this presentation. Could you share the presentation with me? Could we?
Oh yeah.
Like a public link of sorts.
Yes. Let me stop sharing my screen.
That would be amazing.
Let me grab everybody a link.
Maybe, I don't know if you have, like, for example, I have a Google Drive with all of my public presentations. Something like that. Anything that, or like just a list of resources, that would be amazing as well. So I can.
Yeah, I have everything.
Amazing. That's great. Yeah. Anything you want to ask me?
We chatted before.
You don't have to. Just a lot of times, you ask questions and you're like, well, maybe they want to, like, yeah.
Yeah, no. I appreciate that. No, this is always so fun, and I think it's nice to give. I think, I love just the idea of having women within the cloud native community or whomever, come and share their knowledge and really talk about technical topics. Just because, I think something that a lot of folks might not know is that oftentimes people who identify as female, you get asked to talk about less technical things. And and so this is a nice opportunity to just kind of dive in and share things that I enjoy and I'm passionate about, and hopefully, it'll encourage other people to want to learn about it too. So I'm thankful for the opportunity and just the focus on this particular focus on women.
Thank you for joining. That was really the goal of, like, giving women in the space to talk about also more technical topics. Like, I don't like it as well when I'm constantly, I can speak once in a while about something non-technical or like my career or so on, but right after time you talked about your career. Like, your career is not going to change that much within some months, right? Yeah. Exactly. Yeah, I want to just thank again the sponsors, the supporters of this live stream, Commodore and Accra, for giving me first of all, the space and time to work on these videos, as well as Commodore for helping me set up these live streams. Do check them out. They are an end-to-end DevOps platform. So do check out Commodore if you're curious. They also have a free version available if you want to get started with Kubernetes. They make it very easy to get further insights into your cluster as well. So that is that by that. Amazing. Thank you so much again for taking the time, Hannah, and everybody who joined this live stream. If you have any questions, if there's any specific topic you would like to see, then please do let me know in the comments as well. I would love to hear any suggestions. Amazing. Have an amazing day, Hannah. It was great to have you on the live stream again, and let me know when you want to come back.
I will. Thank you all.
Amazing. Bye-bye.
Bye.
Bye.